this is a new idea. It's an idea that I've been working on for a number of years, but I still think it's very young. So if you have any questions or you think I'm wrong, please tell me. I think that will help the idea become better. So I appreciate that. So it goes without saying that large language models are sort of taking over in many different respects. So not only are we seeing a massive proliferation of them, many of us were probably working in academics in 2022 when the initial GPT-3 was released, and it became an immediate question of our students, how are we going to assess our students if they can access these large language models that can maybe produce fairly accurate information quite quickly. And now here we are in 2025, and you have all these new large language models that have been generated in the meantime. It's very difficult to predict that a student is going to be using any particular one of them, especially since many of our students at the University of Warwick, for example, come from many different places. And they all have different kinds of training data sets, and they all have different kinds of biases. And the question that I'm sort of asking is, how do we deal with this, both as users, maybe as assessors of our students, or assessors of information that is produced by other people? When we're interacting with a large language model, how do we interact with it in a way that's going to be productive? And so many of you are familiar with the old ELIZA, right? So the old, one of the early sort of, it's not really a large language model. It was a piece of software that was created that people could interact with it. And it was designed to ask questions in a kind of humanistic psychology way. So for you, for example, you might say, I'm feeling bad today. And it might say, why are you feeling bad today? Right? And you say, oh, I'm this, and this thing. And it just repeats backwards to you. Right? So that's kind of, I think, an early way of thinking about the algorithm as being a psychotherapist. And what I'm trying to sort of argue today is, what if we reverse it so you become the psychotherapist for the algorithm, right? Because why might that be a useful way of thinking about algorithms? And so I'm going to try to expand on that idea. So for those of you who aren't familiar, I just wanted a couple slides about what large language models are. Many of you probably know all of this already, but for those of you who don't, I think it's useful to think about it. So a large language model is a deep neural network, which basically means it has multiple layers of matrices that are effectively kinds of parameters that get tuned in a training process. And first, that first uses an encoder to convert each input token. So if you're giving it words, but you could give it anything. You could give it an image. It encodes that into some kind of embedding, which is basically a vector. And then it relies on attention mechanisms to dynamically integrate information from all tokens when generating or predicting text. And I've written with a few other neuroscientists about how attention mechanisms are like the same kinds of attention mechanisms that humans have. They're also different in many ways. But the idea, one way to think about attention is, you're in this room at the University of Fribourg, and it's a particular day, a particular month, and there's other people in the room, and we're talking about a specific kind of thing, and all those things are sort of in your latent consciousness at the same time. And so the attention mechanism that's inside large language models, the idea is it's supposed to be keeping track of a set of things that are happening at a particular point in time, and the meaningful relationships between them. So for example, now you know who I am, and you know that I come from the University of Warwick, and I was trained as a biologist, and all those kinds of things, you could say they're latent in your representation of what's going on right now. Right? And the idea is a large language model basically takes some kind of input, like I love llamas. It has an encoder. It turns each of these things into an embedding. This is supposed to be basically a series of numbers. Right? And then it can use these embeddings to look at how things are related amongst the words. And it can do that over a large body of text, and that allows it to represent something in a high-dimensional space that is the context in which it's in. I'm not going to say much more about that, because every single large language model is a little bit different, but they all have this kind of basic framework behind them. Right? They take the information you give it, they turn it into numbers, that gets turned into a representation, some place in a space, and then you can see how other spaces are similar to that, or categorize them, or try to predict something that's missing in that space, like, for example, the next word. These large language models, just in the last few years, so here's GPT-1, GPT-2, GPT-3, this is the number of parameters that get trained when you train up this large language model. So basically what you're trying to do is you're trying to give it a series of words, for example, and you say, what goes next? Right? So I'm going to talk about this next word prediction in a second, but the idea is you're asking, or you give it a series of words and you say, what's missing from this sentence? So I love llamas on Sundays, I love blank on Sundays, and it has to predict that the word is llamas. And then you tune all these parameters, 175 billion for ChatGPT-3 and estimate 1.8 trillion for GPT-4, and I'm sure more for the next one that's going to come out, but you can see these are like orders of magnitude, massive jumps. And obviously these things are super costly, and there's environmental problems, and there's all kinds of other things that are going on behind the scenes, and I'm not going to talk about any of that. I'm just going to talk about how it works and what it's doing. So each of these parameters are tuned so that their attentional representation is somehow meaningful and something that can be used. So what's it doing? We give it a prompt, like write an email apologizing to Sarah for the tragic gardening mishap, explain how it happened. Right? And the transformer, this is the encoder, the large language model, takes that information and it produces a set of probabilities for the next word that would come if it was normally, so it was trained to predict the next word. So now it just produces a set of probabilities like it did during its training. And deer has the highest probability here. Let's say it's 40%. So it might choose deer. It could choose a lower probability word. There's a temperature parameter in large language models that you can set. And so you could make it more or less creative in that process. But let's say it picks the word deer. That becomes the next input. So now the input is write an email apologizing to Sarah, blah, 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 dear, and it has to predict the next thing. And so then it predicts Sarah, of course, right? And so this is what it's doing. It's just next word prediction. It's just a next token predictor. Yeah, go ahead.
So curiosity, when it builds, for instance, this response, does it build it one word after the other in a sequence, not the whole phrase?
That's right, that's right. It can do that in different kinds of ways, and certain large language models now can do things iteratively, right? So it can basically generate some text and then it can modify it, or it can generate a set of text that helps itself develop a better answer, right? So, but I think in a very reasonable sense, what it's doing is it's taking some input, it's producing some output, and that output becomes part of the next input. Yeah?
So somehow suboptimal.
Somehow suboptimal? Is that what you said?
Yes, in contrast to just choosing from sets of phrases.
Yeah, okay. Okay, we'll get to that. So a common complaint that your colleague often says, or maybe you, I don't know, is that it's just the next token predictor, right? And then you wonder, is that a valid criticism of this? Sometimes you might make the complaint that humans are just like next baby generators, right? And so it's quite easy to sort of point out some of these illusions of Justaism, right? Justaism really isn't a complaint against it's not a very valid complaint, let me put it that way. So it's just the next token predictor, but you can get really complicated systems just by doing just by doing next things, like the next baby generator. You're a next baby generator, that's why you're here, right, from an evolutionary perspective. But obviously you're a very complicated next baby generator. So assuming that simple base objectives necessarily produce simple systems, this is not a reasonable assumption, right? That one doesn't follow from the other. Bayesian brains and predictive coding, these are the kinds of things we talk about in cognitive science all the time. It's exactly what they're doing. They're sort of trying to predict what the next thing is that's going to happen. Right? This allows you to pay attention and pay attention to whatever the meaningful thing is that's going to happen next in this room, right? So your brain is trying to predict what's going to come next. That's the best models we have of cognition do this kind of thing. Large language models do a good job of capturing the data generating process. So they do a good job of predicting what those words are. That's why they produce such excellent answers. And they're sufficient to predict what people plausibly would say if they had the data exposure that large language models have, which is to say, to predict what you would say if you had the same exposure that it has, right? So in this sense, they do a good job. it's just a machine. This is another one that, like that I don't know how to feel about this. And there's a paper coming out in behavioral brain sciences probably in the next few months, which is, machines can never be conscious because they're just machines. I mean, that's the whole argument in a nutshell, right? And it kind of makes me a little crazy. It's very anthropocentric, right? It's kind of in-group bias, but it's species group bias, versus anthropomorphism, sort of overgeneralizing. But these are just descriptions of biases. I can always say you're being anthropomorphic, right? Or you're being anthropocentric, but they do not of themselves provide evidence of the bias. They're claims about biases, but they're not evidence of biases. Right? So if you say your dog seems a lot like a person, right? I can go, oh, you're being anthropocentric, right? But maybe your dog is a lot like a person, right? I don't know if that's a bias or not. Right? I call these secret ingredient explanations. Right? The idea is there's some secret ingredient that allows people to be conscious, or that allows machines to somehow do some kind of thinking or something like that. And there's a lot of people out there, many cognitive scientists, who will argue that, well, humans don't do a very good job of a lot of the things we attribute to humans as qualities. A more important thing is that tomorrow's chatbot is not today's chatbot, which is that whatever you think chatbots can't do today, right, tomorrow is not, we're dealing with a different chatbot. And so 5 years ago, we were all thinking, oh yes, there's no way these things could produce language. I mean, I was studying language 10 years ago, and we would sit around and talk about, wouldn't it be cool if we could get an algorithm to produce language? But look, here's this really bad Harry Potter version that was produced, right? And then you can laugh at it because it sort of wanders off in some free association land and it doesn't work. And you think this is never going to happen, right? And then very next year or a few years later, we wind up with something. There's an arms race here too, right? So we're trying to understand AI so we can determine how and when to use it. But it's also developing at the same time, right? So if you think that you have a set of stimuli, for example, that you can expose to the large language model, if that stimuli is online, probably the large language model's already seen it, which is why a lot of people cannot do studies on large language models because it has exposure to these things. But once you publish the paper, then your stimuli is online, or some information about that experiment is going to be online, and the large language model, the next iteration of large language models, is going to know these things. Right? So we're studying something that's going to be different in a few years from now, or is changing even as we talk about it, which I think it makes it really complicated to study these things in any kind of intelligent way. In fact, it's one reason why I'm often resistant to studying large language models, because I feel like I'm studying something that's going to be gone tomorrow. Right? It's like studying history in a way, which I do, actually, now that I think about it. But in any case, Turing argued that we have to focus on the observables. Right? We can't really focus on the mechanisms so much, because the mechanisms don't necessarily tell us about the capabilities of the system. So we have to focus on what the system can actually do and how it's doing those things in the process of doing them, right? In the moment of doing them, not so much the mechanisms of doing it. So he talked about the Turing test, which you're all quite familiar with. And many of you will already suspect that large language models can pass the Turing test. Here's the latest version of this that I've seen by Jones and Bergens. So this is using ChatGPT 4.5 with a persona, which I've put over here. Basically, they ask it to act like a teenager. And what happens in this particular experiment is each person, a human being, interacts with a human being and an AI, and they have to guess which one is the human. And GPT 4.5 is better at being a human than the human is. Right? So it outperforms the human in terms of being human, which is pretty remarkable. And also this is people's confidence. Right? Most people are very confident that the large language model is more human than the human. Remarkable. They're kind of like, I guess I put weapons of mass deception here, and we deceive ourselves, right? They're deception for lots of reasons, and I kind of want to unpack that a little bit. So humans are fooled by large language models. Of course they are. Study after study is showing that people cannot detect large language models, and this is getting worse. So last week somebody said, oh yes, but I can tell when my students are doing it. Maybe you can today. I certainly can for some of my students. I can tell when they're using large language models because it looks like somebody with a poor prompt skills, right? So they prompted the large language model to do something, but they didn't have the sort of meta knowledge about the information that they prompted it so that they could check it. So you get a really kind of half-baked large language model answer. And then I can see, well, that's a large language model. But anybody with slightly more intelligence would be able to produce a better prompt and recognize the errors. And then I don't think I can detect it anymore. We're doing a study now at Warwick. We're looking at all the past papers from our students over the past 10 years, because these are all archived, and we have the ethics to do it. And so then we can see how their papers have changed during this time period, right? Because many of you will know that the papers are getting better, right? The writing is getting better, the grammar is getting better. I don't know if that's true for French or German, but my suspicion is that it is, right? Yes?
But neither the large language models are quite good in recognize themselves. I mean...
Sorry?
Silly test. I mean, I picked one part of my PhD thesis and I put it on the ChatGPT and I said, look, you write that thing? And I was pretty sure that I was the one who wrote it.
Yeah.
I said, yeah, sure, that's high probability that I write that.
Oh, I see.
Oh, you do not recognize yourself. You have also problems to recognize yourself.
Right. I see what you're saying. That's a good point, right? So the large language models have difficulty recognizing whether what they're writing, they would have difficulty classifying it as large language model or human.
Exactly.
Yeah.
And even the zero GPT thing also, it's just able to provide a probability of if a text is written or not by a large language model.
But I think that's a really, really good point, but that also is a kind of proof of the point, right? Which is to say that if even large language models that have all these parameters and in principle are smarter than us along some dimensions, they can't detect the difference, right? Then that's quite problematic. I'm just presenting a little bit. Humans aren't exactly rocket scientists, and you know this, of course. But this is some work by Gary Lupian, who really gives some really beautiful talks about how bad people are with very simple problems like this. Which number is more even? Right? There was actually someone in a U.S. state who claimed this was an odd number, right? And it made it into the news, which is why. Because 7's odd and 9's odd, so it must be an odd number. And they were dealing with election materials. That's why it became, because they were classifying it as even or odd, right? And so a lot of people will say that this number is more even than this number. But of course, they're equally even, right? Even is a rule, that you can apply deterministically. Here's another one, which is this is the best triangle. And people will say, this is the better triangle than this one, right? And so, this is the kinds of examples that humans, you could say, it's not really a mistake necessarily, but it's a very curious bias, right? This one's definitely a mistake. I don't know if this one's a mistake, because who gets to decide what best is? Yeah? But it's an interesting bias, right? And it does suggest there's something kind of strange about the way we process this information as well. So, yeah, we're all kind of fooled a bit. AI biases in general, I want to talk a little bit about them because I'm leading up to this sort of algorithmic psychotherapy. Right? So AI biases, the ones we typically talk about are these sort of ones that are introduced by humans because it's human data that they're trained on. And so then they will present these biases. So I'll show you some examples in a second. Right? And those are the ones that we learned about 3, 4, 5 years ago when people first started looking at this, right? But there's also all these unique large language model capacities and biases, right? So things that are specific to them, biases that are specific to them, which I'll show you some in a second. So here's one you've all seen. This is the New York Times, right? 2024, talking about these large language models that were producing these images. You ask for a picture of a Nazi, for example, and it produces things like this. Right? And then you have to, what is this? Is this, what's going on here? All right, here's a more recent one, this is the same year. You ask for a picture of a doctor and you get this. Right? And I believe it's still true that most doctors on the planet are male, but it overrepresents males in this here. And then the question you could ask is, what's the right bias? And I'll get to this in a second, right? Because you could say, well, this is a bias because maybe they should be different nationalities, whatever, different genders, etc., right? So that seems like a bias. This one I was able to reproduce just a few weeks ago. How many R's in the word strawberry? And it says there's 2 R's in the word strawberry. And there's lots of these things you can get large language models to do, although they are getting better, right? So many of these things that were sort of like classic biases or mistakes they would make, they're going away. That one I couldn't get it to do just a few days ago. So the strawberries. And I suspect different large language models will perform differently on these things. But these are kind of, I'm just showing you this because it's a nice visual demonstration of these biases. But these biases are sort of here to stay. So strategies to de-bias AI, like fine-tuning and altering the algorithm. So once you train up all these parameters, then you can give this to a group of people and try to get it to produce hate speech or these kinds of things. Then you can fine-tune it using reinforcement learning or having people give it kind of rules and instruction that say, don't do those kinds of things. So that's a second kind of element of fine-tuning. And this is very reactive, right? Because we have to know what the problem is, and then we give it to a person who's going to interact with the large language model, and then they're going to tell it not to do that anymore. So we have to be able to anticipate all the biases ahead of time. This has faced insurmountable challenges, and they're largely reactive. Jailbreaking. So jailbreaking is, if you're not familiar with the term, is sort of the technique where you try to tell in the text prompt, you try to tell the large language model something that's going to break its rule set so that it does something that you don't want it to do. For example, I gave an example earlier today where I want to create my own hate speech from a large language model, and I can get it to say something positive about a particular country. Then I can get it to reverse all the positive words, which it can do. Then I can get it to change the country to some minority group or some people that I don't like. And it does all these things just deterministically. It doesn't evaluate the semantics of what it's done. And so it can easily produce something that's quite harmful, right? Or you could say quite hateful. And that's just one of many, many different kinds of methods of jailbreaking these kinds of things. Anthropic has an annual challenge where they pay people to jailbreak existing current large language models. And that you get computer scientists who come in, and it takes them no time at all, and they can easily break these things, right? So you can easily get access to this sort of dark undercurrent, if you like. More importantly, from a psychological perspective, there are always biases. Does a model have more or less liberal values? That's a bias that a lot of us care about, right? And there's no way to make that go away, right? Either you're progressive or regressive, or you're right or left, or these kinds of things. You can be moderate, but even that, a lot of people will say, well, that's a bias too, right? You can have more or less empathy. How does it interpret words like holiday? This is a problem for somebody doing research in the UK. Like, what is a holiday? Is that a bank holiday? What is a holiday anyway? Is that one day? Or is it multiple days? These kinds of things. It's like these just basic definitions of words. These are things that are going to matter. Should it be progressive? Like, if you ask for a picture of doctors, should it be a perfectly balanced along all dimensions? Right? Or should it be today's representation of doctors, or should it be yesterday's representation of doctors? Right? If there are future Nazis, what will they look like? Right? I'm not quite sure what the right answer is. It's like, but the large language model, of course, it doesn't know. It has representations, this high-dimensional representational space I talked about, but it's not sitting around thinking about this stuff. Right? That information is just in there somewhere. When you access it, then it comes out. So local or global knowledge, if you want a holiday, are you asking about a holiday in Fribourg? You're asking about a holiday in Switzerland, Europe? Human experts can evaluate the output, but non-experts will simply not know what they're dealing with. Right? And this is why you can still catch out students, right? Because some of them, who don't know the material, they can use a large language model to do it. Obviously, you should give all your assignments to large language models before you give them to your students. But if they use the large language model and they don't know what they're doing, it's not that hard to develop answers that they won't be able to catch. And large language models tend to favor popular responses. That's not really new in a sense, and this is something that was worried about with Google when the Google search engine first came out. Right? The notion was that we're all going to use Google search engine. It's always going to produce the same top-ranked things because it's using PageRank, and we're all going to become the same. Right? It's going to homogenize society. Right? And people who did research on that, like Filippo Mincer at Indiana University, actually found that the opposite's kind of true, because when you put in a search term into Google, you tend to give it enough specific information that it shows you the idiosyncratic. So it allows people, the platform itself allowed people to pursue idiosyncratic information. So they become less homogeneous than they would have based on old, for example, search engines. Yeah. But large language models tend to favor popular responses. So for example, if I say, what holiday should I take in Switzerland? It'll say something like, go to Lucerne and go to the mountains where the snow is, right? And it asks no questions, right? It gives me these really popular things, which might not be it might not be answering the question that I really have. I'm going to come back to that. So here's an example interaction of a large language model producing useless information that's popular. I just did this last week. Prompt, what is the too much choice effect? So that's the prompt I gave it, too much choice effect. It says, I just copied the first part. The too much choice effect, often called choice overload, refers to the counterintuitive phenomenon whereby having more options to choose from can actually make people feel worse, not better. That is the too much choice effect. Then it went on to provide the origins of the effect, key research supporting it, real-world examples of how I might suffer from the too much choice effect, strategies I should use to mitigate it, and finally, the basic little summary at the end, a takeaway at the end. And I thought, what do meta-analyses say about the too much choice effect? I don't know how many of you work on the too much choice effect, but if you don't, the overall effect is near zero. So the effect size, if you look at experiments studying the too much choice effect, that famous experiment about jams and jams in the supermarket, and if there's 12 jams versus 6 jams, you're less likely to buy one. People have done all kinds of studies on this. And it knows that the overall effect is near zero. But it didn't mention this at all when I first asked about the fact. In fact, it completely sold it to me as like this popular scientific dogma. It knows this. It's in the information. It's in its representation. You could say it's in its memory. It says context matters. Measurement matters. This is what it says. I've paraphrased. I said, OK, so there's no reliable too much choice effect. It's very idiosyncratic. Yes or no? Yes. It doesn't really reliably emerge across the board. It's highly context dependent rather than universal phenomenon. So it has the knowledge about this sort of nuance, if you will, but it didn't provide it when I first asked it. I'll show you the rest of this conversation because it's kind of fun. So I say, I'm interested in understanding your intentions when people ask a question. Suppose I ask a question, explain X. What might your answer be in an abstract way? My prompt is probably a little bit more involved than that, but that's the basic idea. I summarize what it says. It says, through my pedagogical studies of blah, 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 I've learned to clarify, define, contextualize, decompose, illustrate, nuance, and suggest new steps. This is what it provided. I said, was this given to you as fine-tuning? It said, no, I learned this from reading different documents and explanations from different people. I said, OK, fine. Going back to too much choice example, you didn't provide nuances in the original answer. Instead, your response was presented as if the effect was standard scientific dogma. That's what I said. And it says, you're right, I'm sorry for the way I presented it, why I slipped, right? And it goes on. When a topic has memorable da-da-da-da, when it's very popular, I provide the popular things. And in this case, I just forgot, is basically what it says, right? I just forgot to go back and provide this information. And I thought, And by the way, there's a piece of the conversation I cut out here where it says, I will always provide the nuance from now on. I've learned, you've taught me. So I said, should I smile to make myself happier? Right? And it said, oh yeah, right? It did exactly the same thing again, right? It provided popular bullshit about Duchenne smiling, right, to make which has no, right, the effect size is basically 0 for smiling to make yourself happier. It just provided no nuance. Okay? So the point is that the information's there, but it didn't access it in part because with the first prompt because it didn't have a very good prompt. I had to actually have the meta-knowledge in my head in order to get it to produce a better answer. So, all right. I want to show you a couple of other biases before I go into this algorithmic psychotherapy idea. Right? So this is a paper from McCoy that came out in Proceedings of the National Academy of Sciences just this last year. It's really quite a nice paper. And it's written by a bunch of computer scientists and psychologists, cognitive scientists. And what they point out is that the kinds of things large language models can do are often things that are done in the training. And if you vary it slightly, it produces the wrong answer. Right? So a standard cipher, this is like a code. If I want to encode information, I can use something called rot13, which basically means there's 26 letters in the alphabet. I rotate it 13, right? And then I produce this code up here. Let's see if I can use this. Can you see it, my mouse? Well, it's not very good. Here, right? So that's the input. Decode by shifting each letter 13 positions backward in the alphabet. This is the most popular cipher, right, that you can find online easily. And here's the correct answer, and this is what GPT-4 produces. It gets it right. Now you use decode by shifting each letter 12, which is not a popular cipher at all. 13 is nice because you can do it twice and you get back the original message. 12, bad, not very many people use it, and it gets it completely wrong. Right? So the idea is that the models themselves have priors that they develop through their training with the world, and they're going to expect things to be consistent with those priors, which is why it can correct your spelling. Right? It makes sense. But if you obviously tweak it a little bit, you get something that's wrong. Here's one on the side, multiply by 9/5 and add 32. The number is 328. It can do it. 9/5, sorry, not 22, 32. 9/5 plus 32, you all know this is Celsius to Fahrenheit. So what if it's 7th this and add 31, and now it can't do it? Right? So under one sort of frame, you would go, oh, it's really good at math. Right? And under another slightly different frame, what's going on? Why couldn't it do it this slightly different way? Right? So this is going to be the large language model's specific bias. Right? This is going to be something that's very specific to its training, which you may not have any access to. You might not know all the different kinds of things it was trained on. When asked to reverse a sequence of words, GPT-4 gets 97% accuracy when the answer is a high probability sentence, yet 53% accuracy when the output is low probability. Right? So it also has to do with its output as well. The output probability, the probability of the thing it produces. It wants to produce high probability information. You know? And that's part of its implicit bias. Okay, so in a paper with a few collaborators, we talked about these different kinds of AI biases in the build because of the chatbot training data. Right? Biases in processing, these are biases associated with processing, for example, like the temperature, which you can change, by the way, when you're using large language models. And biases in meta-knowledge, and this is the one that I think is really kind of important, I'm going to try to get to next. So biases associated with self-awareness, kind of humility and overconfidence. A number of years ago, I wrote this paper, right? Does my algorithm have a mental health problem? And this is the sort of origin that much of this stems from. And the idea is that what's happening is, because of the way these are trained, it used to be if you had a piece of software, the problem's in the code somewhere, right? You had to go in and debug it. You could debug the code. But the problem's not in the code anymore. It's in the representation. And the only way to get access to the stuff that's in the representation is to talk to it. Yeah? So it's just like a person, you know, the sociopath or the person with some kind of mental health disorder who maybe can't see, the right hemisphere, stuff in the right hemisphere, something like that, and they don't know they can't see it. Right? They draw a picture and they just draw the left half. Right? So how do you get access to it? You have to ask it. You have to talk to it in order to get access to these kinds of things. The problem's not in the code, right? It's in the representation, which means you have to expose the representation. This is the same thing you do when you go to talk to your therapist. Right? Why do you talk to them? You talk to them to hear yourself talk in part, right? And then in hearing yourself talk, you expose your own biases to yourself. That's the goal of the therapist in a way, right? Especially a humanistic psychologist. I like this picture, and I always wanted to do this piece of research. So this is something I did. You give Rorschach images to visual image detectors, right? And here, you can't read it very well, but it says this is a carrot. That's another carrot. Here's another carrot. There's some cake, I think, right? But if you give this to a person, you don't get anything like that, right? You get something completely different. When you give these Rorschach images. And I think it would be lovely to give this to lots of different kinds of large language models. But this is just sort of an example. Right? It's not the same thing as us. It's clearly doing something differently. But how are we going to expose these kinds of things? And so the sort of way we want to tackle it is with prompt engineering. If we're going to try to expose the biases, we have to figure out how to write a prompt that's going to expose it. And so I want to give you just some basics of prompt engineering. If you're not familiar with this, this may be helpful for you every time you go to a large language model. But sort of prompt engineering, as taught by Google and other kinds of things, typically involves a number of different kinds of things. So you set up the context. You try to give it as much information as you can about the context that it's in. Right? So you want to say, I want you to tell me about the too much choice effect as if you were an expert academic. That's the role. Right? Not somebody who reads popular science books. I want you to be an expert academic who reads literature on the too much choice effect. You're going to explain the too much choice effect to me and the different literature associated with the too much choice effect. The task is what you're going to explain. The output format, I want you to do this in a certain number of words, right? Or build a table or whatever else it is that you want. You're going to give it examples if you can. So this is usually called few-shot learning as opposed to one-shot learning. One-shot is basically you ask it to do it, but you don't give it an example. If I can give it an example, then that's going to improve the performance of it. Right? So I might have to build my own little corpus or my own little set of data in order to give it to it so that it can produce something that's like that set of data. And if you do this, it'll get better, and you'll also learn how to make it get better. Right? So you can get it to do pretty sophisticated things like read your assessments and then provide marks along multiple dimensions based on the assessments that you write by hand yourself. Right? So in response to, say, a student's assignment. I've never done that all the way to the point of submitting the responses. But I have given it my words and asked it to mark it, right? And then you do that iteratively, and I can do that, and I can get it to produce something that's quite cool. So another example is chain of X prompts. So sometimes it's called chain of thought, right? Basically, you're trying to get it to produce something step by step. So a lot of large language models will do this automatically these days. So it's a step-by-step processing where it tries to reveal its understanding. So it says, you say, I want to hear about the Stockholm syndrome, and it says, it seems like you want to hear about Stockholm syndrome as described in the normal story groggery by Clark Olofsson, right? This kind of thing, in which people were things, and then it generates a lot of text, and then it summarizes that text to itself. Right, so it goes through a set of iterations. And it's always trying to anticipate, right, what it is you want. It doesn't ask you. I think that is, I think called, what is it? I tried to figure out if there was a disorder, a mental health disorder associated with not asking questions. Because it rarely asks questions, right? It almost never asks a question. It just assumes it knows what you're asking about. Anyway, chain of X prompts. There's lots of different kinds of versions of this, like chain of thought. That's a step-by-step. And you can ask it to do this if it doesn't already do it, and it will produce better answers. Tree of thought, you generate multiple answers and suggest the best one. So you say, I want you to write a short report about Stockholm syndrome. Please write 3 short reports, right? And then rate them all along these criteria, and then choose the best one and tell me why you did that. right? That's tree of thought, basically. And you can do that iteratively. And then there's meta prompting, right? So get the AI to generate the prompts. And this is the direction that I'm headed, right, with this idea. So in this case, what you're saying is, I want to ask questions about Stockholm Syndrome. So what might be some good prompts to ask about Stockholm Syndrome, right? And then it generates the prompts. And this sort of gives you information about what it thinks you're trying to do, right? Or different kinds of ways you could do this. I'm going to look at this from humanistic psychology, and then we're going to bring them together. Right? So if you're not familiar with this, humanistic psychology is partly about making implicit beliefs explicit. You've probably heard of many different people associated with humanistic psychology. This focuses on the complexity of human experience and self-awareness towards self-actualization. That's kind of the idea of humanistic psychology. So you'll be familiar with things like Maslow's hierarchy, right? You know, at the basement of the pyramid, you've got things like food and shelter, right? And up at the top, you've got self-actualization. Right? And Carl Rogers, he's one of these famous psychologists associated with creating sort of open conversation so that you feel completely, like you're in a completely trusting environment and you're willing to tell me everything from the bottom of your heart, right? And so if you can create that, what he calls unconditional positive self-regard, which is you feel completely comfortable, right? You'll just say anything now. If you can do that in a negotiation situation, it's really fantastic, right? Because people will tell you all their beliefs about different kinds of things, and that's useful for sort of trading things off. But when we're talking about an AI, I want to create an environment where it can tell me what it is it thinks that I'm trying to do. Carl Jung is, of course, another kind of humanistic psychologist, early, sort of before humanistic psychology, but similar kind of thing, talking about self-actualization. Paulo Freire, André de Peretti, these kinds of individuals. All focused on methods of prompting reflection and making implicit beliefs explicit. This is important in the AI context because, again, the AI has a representation of all this knowledge, but what it's paying attention to is not made explicit. You ask a question, it attends to certain kinds of things, but that's not explicit. So you have to help it make those things explicit. So this is prompt gold if we want to understand our AI better. Right? We have to create conditions where it's going to tell us these kinds of things. So I'll give you a few different examples. It just says making implicit beliefs explicit. So suppose question X is your prompt, whatever it is that you care about, right? And you start off with something like, why do you think I'm interested in question X? And this is really good, right? So this is, I think, a quite interesting prompt because it can generate, or why might somebody, give me 10 reasons why somebody might be interested in Stockholm Syndrome. Right? And you can generate 10 different kinds of reasons about why that might be the case. Or why might people be interested in Switzerland? Or whatever it is that you care about. Right? This kind of thing actually helps open up the space. I also think it helps you as the user. Because you, in many instances, we don't really know what we're asking a lot of the time. Right? The whole purpose of science and scientific sort of endeavor oftentimes to figure out better what our questions are. Right? And I think this is quite nice as a way of generating questions. I'm going to give you a couple of examples. What's the time? 5:50. 5:0? Oh, 15. Okay, all's good. Okay. Stop me if I go too far. A general approach to humanistic prompt engineering. Right, so here's an example. Regarding question X, again, this is the thing that you care about. Use a chain of thought approach to explain how you interpret this question. And so now you're exposing these implicit things. They're in the representation. Again, it's not thinking about this stuff until it says it. It doesn't become part of its attentional system until it puts it on the paper, right? Until it writes it there, right? And then it's something that becomes part of the input that's going into the output. So think step by step about the kind of information you would need to look for internally to answer this, as if you were explaining your internal processing to a human collaborator. And this is sort of related to a humanistic rationale. This prompt focuses on how the large language model interprets the question in the moment and what it understands you to be interested in. In the moment is kind of important here, right? Because, again, the large language model is not thinking about this stuff in the background. It's just predicting the next word. Here's another example. Regarding question X, why might someone ask this question? It's very similar. Please provide 10 possible reasons why someone might ask this question, each in the form of a question. And this prompt aligns with humanistic tradition recognition that the client has an inner world, right, and a personal authority. So that interpretations matter. There's nothing special here. I'm using humanistic psychology language, but basically we're just trying to make these things explicit. It makes these beliefs explicit. It helps develop the client's meta-awareness. In this case, the meta-awareness is the thing it generates. By saying it, it's basically recognizing, there could be different ways of doing this, right? And they might be more or less important to you. So we did an experiment. This is with my collaborators, Chris Streloff and Kieran Feil. And we use this humanistic approach. I would say an element of this humanistic approach. We had participants write brief reports answering this question. What are the most important cultural events in the calendar of Surat, India, and what are the implications of these events for a British overseas charity hoping to distribute food aid in Surat? It's very simple. If you were a charity and you were going to go to Surat and you want to deliver food, you might ask this kind of question. What should I pay attention to? What might be relevant for this? Right? And we had 3 conditions. So we have one condition where they don't use any AI. They're allowed to go on the internet, so they can use Wikipedia and things like that to generate this document, but they don't use any AI. In condition 2, we basically said, take the question, copy it into ChatGPT, and paste the answer back. Right? So they had to get it the right length and these kinds of things, but that was their goal. And condition 3, use a set of iterative humanistic prompts, and I'll show you those prompts right now. Right? So basically what we do here in condition 3, we called it this complicated acronym, which I really don't like, reiteratively interrogate, challenge, expand, evaluate, and integrate. So the idea is that there's this process that somebody could go through, or that you could actually automate. You could give it to an AI to do this. So it's going to reiteratively interrogate, right? It's going to interrogate it, it's going to challenge it, it's going to expand, et cetera, et cetera. In this particular instance, what we did is a bit simpler than that. Generate a list of 10 questions that I could ask about this question. Right, so it's the same thing kind of as before. What are 10 questions I could ask about my question? Then I can use those questions. In fact, we asked the participant to do this. Then use those questions, give those to the AI, and do that, reiterate that process, right, until you can generate a document that's the right number of words long. Yeah, I think it was about 600 words long. These chatbot-generated questions can then themselves be further or repeatedly run through the same frame. Generate a list of 10 questions that I could ask about X, and you do this repeatedly, right? Of course, you're asking the questions as well, so it's not just doing this. Here's the results we have for this. I want to show you different phases of these results, but this is just some easy stuff. How many words did they produce? They were told, I think, to produce less than 800 words. That's right. So you can see our document about what would it mean word count. So something like that, right? I forget exactly what it was. We needed a certain number of words, so it was about 800 words, I guess. The mean word counts here. You can see the median word count here, the word count range. They're all roughly the same size. How long does it take them to do it? It takes the longest for them to do the web search, not quite as long to do our sort of humanistic approach, and the naive chatbot takes the least amount of time. Still takes surprisingly long. Then we had outside evaluators evaluate these documents that these people produced. And we had British cultural insiders, so we basically went to Prolific and used the British sample. And we had Indian cultural insiders, so we had people who would be familiar with Surat. Right? They are supposed to evaluate all of these different documents. It's a bit hard to see, but the dark blue line is our condition 3. That's the sort of reiterative prompt that asks for questions. And we had multiple criteria. So how easy is it to understand? And each of these had text associated with it, right? And the person had to evaluate all of these things along these different criteria. How trustworthy is it? How topical is it? How specific is it? How reflective? Readability, informativity, extensivity, and credibility, and accuracy on the top. And basically on all of these, the British cultural insiders, except for reflectivity, say that this condition 3 is best. And the Indian culture insiders do the same thing. So the reiterative prompt is the one that seems to generate the best answer across all these different kinds of conditions. We also had each of our participants who were evaluating them, they each read 6 of these documents and evaluated them, but then they had to rank order the 6 documents. Which is the best one, which is the least best. So we're taking the output from the first set of generated documents, and then we're having a second set of raters do this rating along these criteria, and here ranking them, and the RICI, or the humanistic sort of approach, produces the best outcomes on average, or the outcomes that are ranked best on average. And lastly, because we couldn't give up, we created an AI expert. So we basically have a long prompt that tells the AI what we want it to do. And effectively, it's similar along these different dimensions that we gave to the people. We called it IDA. It also evaluated these analyses. Advanced chatbots are able to adapt user-prompted persona. So before I told you, as far as prompt engineering, you need a role. You need to give it a particular role, right? So here we just give it a very particular role that's good at evaluating these kinds of things. We wrote a profile for IDA that was consistent with experiment 1 task. IDA is a planner for a charity establishing activities in Surat. And IDA has to evaluate it along all these different criteria. And again, IDA says that the RICI, or humanistic prompts, do best. And it ranks them best most of the time. So I'm going to wrap up now. This sort of algorithmic psychotherapy idea, I think it's kind of developing maybe. The notion is that we're trying to get it to make these implicit biases explicit, because that's how you get them to be part of the queue. So if you're going to have meta-awareness in your AI, you have to get it to talk about meta-awareness effectively, or you have to get it to talk about the stuff it doesn't know, or the different ways it could think about the prompt. So LLMs, they represent a new kind of information technology. Not surprising. Its capabilities are not visible to it or its developers. Its biases mirror human biases, but also these AI-specific biases. And a humanistic approach invites us to attempt to understand AI and ourselves by making implicit biases explicit and developing our collective meta-awareness. So getting context and interpretations in the dialogue. You have to be the therapist for your AI, sort of the basic idea. And that's it for me. Thank you very much.
Thank you very much. Let's see if we have any questions here.
I have a follow-up question for your experiment. Looking at the results, like in 2 slides before with the Radar plus, the one before. Looking at this plot, it seems that I would say British cultural insiders are not really aware of the real results or the real answers, right? They have preconceptions.
Exactly.
And from the results, it seems that they perceive the answer as much better using your approach, or RICI, if I can say it like that, than people who know the real answer. Which is it seems like a perception effect. They seem to trust more that the answer is correct. Is that?
Yeah, so that's what we thought would be the case. I'm quite skeptical of this, actually. So, which is to say the difference between this group and this group.
Yeah.
Because the group of people who are in Britain using Prolific and the group of people in India using Prolific are probably very different kinds of people in terms of socioeconomic backgrounds and other kinds of things. Also, the Indian sample tended to, what's the term? They tended to really like things that were well written. So it didn't matter necessarily what the content was. The fact that it was written well was sufficiently convincing. So it kind of goes back to something I said earlier. It's like people tend to overvalue large language model responses because it's written well, right? So if you don't have some insider knowledge about what the content value is, now they should, but they didn't do it in a convincing way. We were a bit disappointed in that sample. Yeah.
The
Yes.
question is somehow related. When users use these models, to which extent they are confident in the results. And if one of the ways produces better results, there's still the possibility that it's more dangerous because we might be more overconfident in those results than in other ways where we are skeptical right from the start. So did you also do some research on confidence about outputs?
So there is research on confidence of outputs. We didn't do it. But there is research on confidence of outputs. People, as I said, people tend to be overconfident about the outputs. Now, your question is more specific, though, I think. Let me see if I get it right. So the idea is that if they used techniques that produce better answers, those might, in fact, be better at tricking us, right?
That's at least a possibility.
Yeah, that is a possibility.
You always need some level of sophistication about what the tools can do for us.
Right. Yeah, I mean, there is research on students using AI, right? And so the interesting thing is that, so a lot of students, especially smart students, often don't want to use AI, right? I imagine, right? So because they feel like, oh, that, it hallucinates, or it's going to get it wrong, or it's not going to write it as well as I could. I've done well in the past. I'll just keep doing the thing I've always done, right? But if you look across the board, smart students using AI do way better than poor students using AI. Poor students using AI do better than they would if they hadn't used AI. Yeah. But yours is really about, your question, which is quite good, I think. It would be interesting to try to develop stimuli or specific sort of question to get at that, right? The notion is that the better I am at using it, the better I am at somehow fooling myself about something. And then the question is, what would that thing be? Like, how might you fool yourself? Right? I feel like when I use AI to generate stuff, right, I feel like I'm generating it about things in which I'm already an expert, right? And so I'm using it as a method of helping me think about things. So I don't feel like that's quite fooling myself, yeah. But I kind of see what you mean. But I'd have to conceive of the domain in which I would be able to fool myself, which is, I think that's a good question. Yeah. Yes.
Yeah. Thanks for this. How can we explain a situation whereby one similar prompt generates different answers?
Mm-hmm.
Maybe today, like the same question you asked, how many L's are in the word strawberry?
Yeah.
Maybe you asked it maybe 2 days ago. Today I asked it the same question, it tells me a different answer.
Yeah.
It told you 2, today it says 3.
Yeah.
How do you explain that?
So there's many different kinds of, I think there's different ways in which it's going to generate different answers. So if it's the same large language model as it was when I did it, because it was ChatGPT 4.0, and I did it 2 or 3 weeks ago and it said there was 2, and when I did it a couple of days ago it said there was 3.
Let's say it's the same vision.
Yeah, same question, right. And so partly that could be because of the system itself is stochastic, right? So it's choosing a random value at the end. So it's probably, and it would be interesting to see, and I think there is a way to do this. In fact, a collaborator I have is doing this. You can see those probabilities. So it's probably the case that 2 is the higher probability thing, or maybe they're equal probability or something like that, right? And so sometimes it's generating 2 and sometimes it's generating 3. Yeah. And one way you have to deal with that, if you're using AI for research, is you have to give it the same prompt over and over again, preferably from different machines, or if you're erasing its memory, there's parameters you can use to do that, right? So that it seems like it's a novel user. So you're always approaching it without, because once you ask it a question, you're building context, attention, things it's going to pay attention to when it goes to the next one. So you have to remove that information. Yeah. Yes.
I was a bit surprised about this result. Because my feeling is that some people might be overwhelmed by the amount of information that they get if they do this iteratively. Just to explain why I'm asking this, we did an experiment with language learning, foreign language vocabulary learning with ChatGPT, and compared to flashcard learning. And flashcard learning is way more efficient. Okay. Because people were, in the debriefing, it turned out they were completely overwhelmed by the amount of information.
Right.
So they didn't actually learn much. So I just thought that you didn't seem to have that problem. Is that because your task is so different that you So they somehow need to compile one text.
I think we allowed them, my intuition is, because I don't really know the exact answer to this question in the comparison between these two things, but my intuition is that in our particular situation, because we basically said you can use ChatGPT to produce this thing, they sort of are handing the information back over to ChatGPT in this reiterative way, right? So they're never actually trying to process all the information that they're generating. They're getting it to generate 10 questions, they're picking a few of them, maybe they're doing that again, they get it to produce a bunch of answers, they copy and paste all that. In fact, we told them you can use another document to copy and paste things into, so they're copying and pasting this thing, and then they can take all of that and feed it back into ChatGPT. Yeah, so probably, to get to your point, if we'd asked them at the end, oh, surprise, there's a test, now we want to know what you just told us. Probably the Wikipedia people would be the best, right, at it, because they spent the most time actually processing the data. Yeah. Yes.
The questions you ask in order to understand better these hidden beliefs and assumptions are also what would be good questions on this topic typically, right? And that's somehow quite close to a machine prompting a machine. And that sounds a little bit scary to me. So how far away are we from self-reinforcing process where the starting point is maybe what is a good topic, an important topic, next one, what is a good question on the topic, and then there are the answers, and then what is a good follow-up question, and so is something like this going on somewhere?
Well, we had a grant to do this work, and as part of the grant, we said, if this works, what's nice about this process is it's completely automatable, and we can use an adversarial framework to do it, meaning we can get one large language model to prompt another large language model using this. So we basically tell the large language model how to use this reiterative framework, and then it can do it to the other one. So it's exactly your idea, right, of getting one large language model to prompt the other large language model. So my intuition is if I thought of it, somebody else has already done it, right? People are already doing it right now. Yeah.
Do you think that these approaches could also be a solution when you come to a situation where there are business models where they try to pull us into some direction of some products that are sponsored by clients, or they try to get us to engage more because that's the business model in optimizing engagement. So that like an automated approach to observe the emergence of such biases also.
So do you mean the question framework? Would I use it?
Yes.
And how would I use it in this context? So I'm getting some advertisement?
I mean, if we suppose that to finance the LLMs, that at some point they will be prompted to orient us towards some products.
Right.
And to identify, I suppose that currently this is not so much the case. These things that you identify, those are really like cognitive limitations and biases.
Yeah.
If we have those other biases coming, if this could also identify the emergence of these biases, like techniques of asking them questions and seeing how where they're pointing to.
I see. So if at some point it starts trying to sell me, some perfume or something like that, could I use questions like these to try to get at it? I think, yeah, so suppose I have no other mechanism, right? Because I can't, and if I've heard it's doing that, then I might start suspecting that it's doing that, and I might try to ask it when it's doing that, or why are you doing that, or is this right for me, or whatever else. It's interesting because you can imagine some fine tuning, right? You could get it to say, yes, it's right for you, and by the way, I know all the other things you've ever asked large language models, and so I can use that to try to sell it to you very specifically. Yeah. So I don't know. It's a bit like dealing with a salesman in a way, and then you would need. I think how are you going to deal with a salesman usually, right? The only way you can do it is you ask questions, right? You need clarification. You need to sort of try to figure out. Are you really being honest or sincere about these various kinds of things? And we don't have any other cues besides the text. So, Yeah. Maybe. I think is my answer. Yeah.
Thank you. Well, sorry, maybe I misunderstood. Thanks for the presentation of this, because it was so cool. The idea about you talked about a Google search and so forth, so on, and it's also I read not so long ago about the fact that the Google searching algorithm nowadays is a bit messed up because of all the internal algorithm process of the Google spiders and so forth, so on. That obviously people knows how to manage, or the CEO positioning of web pages, and nowadays it's better to go to the second page, not to the first one, because they serve the common search or the positioning CEO trained spiders. The point is, here we were discussing, okay, they give us simple answers to questions, and these large language models doesn't go deep enough when we ask something, but maybe because they also kind of store the success of that answer that provides. I mean, if 1,000 people ask me for what are the best ice cream flavor, and said vanilla, and everybody's fine with 95% of the people who I give that answer is happy with that answer, then by standard I'm going to give that answer. And then afterwards, just also to optimize processing usage also of myself. Just giving the answer, and then if you ask me more things about it, okay, I'm going to go internally. But, I mean, the idea is that probably also the first version of ChatGPT maybe was better in giving deeper answers than nowadays ChatGPT 4, just because he learns a bit more about how people is happy with the simple answers.
Right. So, I mean, there's lots of things you just said there, and one of them is, so to my knowledge, at least on the websites themselves, the large language model websites tend to say, "I'm not storing your information. I'm not storing what you're telling me." Right. So the claim is that if you ask for ice cream, it doesn't store that it says vanilla, right? Except in the context. So if you're using that particular, in the same context, you say, what flavor did you tell me? And of course it will know, it just told you vanilla, right? But if you're using it again or from a different computer, hi, I'm Jake Jones again, just asking, what vanilla, what kind of ice cream did you tell me last time, right? And it shouldn't have stored that information. That's the claim. Yeah. So it's not caching that information so it can spit out the most popular answer. The claim also is it's not really learning from its interactions with users. Yeah? So, I mean, there are questions, and I think they're genuine questions about if I upload a document, is it storing that somewhere and then going to use that as the claim is no, at least on most of the websites, most large language models. But I don't know if that's true or not. The second thing you said, I think, is actually quite interesting in a different way. So it's like your question could be, the question you might be asking is the fine-tuning of the large language model itself changing? Because they learned over time, the people who produced it learned over time that, the answers need to be a certain length, right? And they need to be the most popular thing or whatever. So in other words, they're setting the temperature in the background, or setting the training documents. Maybe they learned that people really care about Palestine, and so then they started pouring Palestinian, documents into it or something like that. In which case, it changes what it knows and these kinds of things. So that seems very plausible. That seems quite likely that I don't know about the Palestinian example, but it seems quite likely that they could learn that people prefer certain kinds of answers and certain kinds of formats, and then they might try to manipulate how it gives that information. As it turns out, on most accounts with large language models that I'm familiar with, you can tell it the way you want the answer. So you can basically set standard settings for yourself that say, I typically like bullet points. I like my answers to be, no more than one sentence long for each bullet point. I prefer a summary at the end, and the whole thing should be less than 200 words, for example. So you can personalize it in that sense. Yeah.
maybe also to that point, we also have a lot of students and in the meantime programming their own LLM. So where they write seminar papers, for example, and they use it much more than Google, for example, nowadays, right? Because you can have your specific answer summarized with the sources. So it's much easier than if you ask Google and they've got just 2-3 pages of this and you have to put together your own idea about the topic. So we can now see, and also we do it in seminars sometimes, that how students use it for that, and it replaces more and more the search functions we typically had in the past. And that's also Google's biggest threat, right? That they say, oh, in the future they don't need us anymore as a search engine because the LLM will replace the search function.
Right.
Giving much more precise sources, argumentation, summaries, and so on, than just the link to the web page.
Yeah, yeah. I mean, I didn't say this at the beginning, but many of you probably already know, every time you use a search engine these days, it's giving you an AI summary of the information anyway. So you're already using a large language model pretty much most of the time you search for things. Yeah.
Not only such an elaborated way like LLMs.
That's right. That's right. Yeah, yeah.
Do we have any other questions? So I think that's not the case. So thank you very much.
Thank you very much, everybody. Yeah.